Hi, I'm Mike Sheehy, Cloud Transformation Architect with Nutanix. Today we're going to talk about and show you how to simply migrate a multi-tier application to the cloud. This is a common use case that we see at enterprise customers. They typically look at either refactoring the application and redesigning the application around microservices, or even implementing an application or moving an application to a SaaS-based offering, or they're lifting and shifting the applications that they have on-prem. This is a very expensive proposition when using cloud-native services. Nutanix delivers a real value and differentiator around TCO when delivering Nutanix within the cloud. And what we're doing is we're running our software on EC2 bare metal instances in the cloud in your VPCs. So let's get into the demo. Today we're looking at the Nutanix Clusters portal. As you can see here, I'm located in US East Ohio in my region, and I'm using availability zone US East 2A. You can see here I have information about my cluster. The status is hibernated. We'll talk about that in a few minutes. The cloud provider is AWS. You can choose between AWS and soon Azure. I'm using my current AWS cloud account with my cloud account ID. I'm using, again, the region Ohio, and the cluster was created by me. You can see here on the properties of the cluster the number of cores, the memory capacity, storage capacity, and of course licensing details. And you can view cost analytics in our cost governance solution we call Beam. Up to the right hand corner you can see the actual bare metal instance summary. I'm using Z1D metal instance type. There are several instance types to choose from. I'm in US East 2A. This is my VPC that I'm using on this subnet, and of course the management subnet is disabled. Here you can see the Nutanix software version that's running on this cluster. Let's go back to the status of the Nutanix cluster in AWS. You can see here it's hibernated. Hibernation provides real tangible value back to the business. And the reason why that is because we are able to actually put the compute of Nutanix cluster back into the Amazon resource pool for other customers to use. That way the customers are not being charged or billed for that compute resource. And we're taking a snapshot of the cluster state and the data and storing that in S3. So when you're ready to resume the cluster, it'll rehydrate the data back and put the cluster in the exact state it was in right at the time of hibernation. Now there's real value in this in several use cases. I'll just choose a couple. One, test dev use case. Maybe you have test developers who need access to infrastructure right away, and you may not have that infrastructure, or they don't have the time to wait for it. You'll be able to spin up this cluster within 30 minutes in AWS and start consuming the infrastructure resources immediately. Another use case is around retail. And retail typically has seasonal workloads, and sometimes they need to burst and they don't have time to wait for infrastructure to be installed at site. Even though Nutanix is pretty quick, we still have to wait to procure the solution, ship it on site, and then install the solution. With this instance, we're able to access infrastructure right away, and again, spin a cluster up in 30 minutes, burst out to the cloud for the resources required for that seasonal workload, and then put the cluster back into hibernation, saving the data in the cluster state for future seasonal workloads. So to begin, what we're going to do is we're going to bring this cluster out of hibernation, and we're going to choose resume. You can see here the status here is wake up cluster. The cluster is called outer_rim. While we wait for this cluster to spin up, let's go over and look at the application we're actually going to migrate into the cluster. So I go to the Prism instance, which is our management plane. We're going to go into the actual application itself and have a look and see what this application is. The application is called Task Manager, and this application essentially is a multi-tier application running a database backend with MySQL, an HA proxy load balancer, and web services running Nginx. And you can see here we have 3 services. Let's actually go to this service to actually see the application in action. Let's click on HA proxy, and you can see here the IP address. We'll copy that, open up a tab, and we'll go to the application. Again, very simple application we call Task Manager. I'm going to add a couple tasks in here. We'll call it Task 1, Task 2, and we'll add one more, Task 3. So the reason why I'm adding these tasks is you can see there's actually changes being made in the application. So when I migrate this application into AWS, Nutanix on AWS, excuse me, what's going to happen is you're going to see that these changes carry over. Now you can see I'm accessing this application from my workstation, but there are security policies built into this application as well. Let's go look at those. So within Prism, we're going to go to security policies, and we're going to look at the security policy that we have set up for Task Manager. And there's a policy called Task Manager _secure. This is a network security policy. It's all network and a microsegmentation security policy. So I'm controlling inbound access to this application. I'm controlling the access within the application between the virtual machines and the apps within the entire application, and of course the outbound access. Let's talk about this for a minute. So you can see this first IP address ending in 199. This is the actual workstation I'm on right now. And this access I have set up is SSH access into these virtual machines so I can actually deliver or connect, and make any changes I need to the application or the VM itself. Another thing that you see to the HA proxy is you'll see that I have another service that I have access to for HTTP. This is for me to actually access the application. So I'm using this IP address, and I'm using those services, which are predefined within the security policy solution that we have here, and I'm able to actually add those and get that connectivity. The second IP address here is actually Prism Central, which is the interface that I'm on now, and Prism Central needs to have access when I'm deploying these applications to make changes to these applications. Now let's go to another workstation that doesn't have access and see what happens when I try to access the application. So I have a workstation within my environment here called Workstation. I'm going to launch the console. And I'm going to log in and connect to the same website. So we knew the website was 192.168.168.50.100. As you can see here, when I try to go to this application, the Task Manager application, I cannot access it. Now the cluster has come out of hibernation and is now into running. You can see the status in the multi-cloud management portal here. Let's go into Prism now and see if we can see the cluster within the management framework. Within Prism now, we can see our cluster called Outer Rim, and I can get details about this cluster here. What version it's on, how many resources I have, metrics, I can upgrade software, etc. The same with any other cluster running in any other location, including on-site and in the cloud. So let's initiate a failure or a movement or a migration of this application into the new cluster Outer Rim on AWS. So we're going to go to Bookmarks, Recovery Plans. So a recovery plan is basically an orchestration very similar to how you would orchestrate a disaster recovery. Is very similar how what we're going to use to actually migrate this application. You can see here I have a recovery plan called Taskman on-prem AWS. Let's click into this and let's go into update it so you can actually view it. You can see here the recovery plan name, the description, the locations. I have the primary cluster Death Star, which is my on-premises location, and my recovery cluster or my remote cluster, that's Nutanix cluster running in AWS, called Outer Rim. Here you can see I have a power on sequence for this application. The Task Manager application again has MySQL, web server, and an HA proxy. And you can see here I'm starting MySQL first with a 60-second delay, web server 60 seconds, and then the HA proxy. You can also see over to the right-hand side I have scripts enabled. So I can actually enable scripts to do things like join DNS, etc., etc. The next thing we do is we map our networks. So we have our on-prem networks. I have a network called Server IPAM. That's a network running on the Death Star that actually delivers IP address management to all my applications, and that's mapped to this server AWS network that's running on the Outer Rim cluster within AWS. So let's get out of this, and now we're actually going to initiate a failover. So I'm going to do a planned failover. You can actually choose to live migrate it virtual machines without interruption, but in this case, I'm only going to do a planned failover, and it'll send the most recent changes in a delta. So here we're going to pick the cluster, Death Star, which is my on-premises cluster. My target cluster is Outer Rim, and you can see here I have 3 virtual machines. Those are the 3 virtual machines that make up the Task Manager application, and I'm going to click Failover. As I drill down into the recovery plan, I can actually monitor and watch this failover. We're going through a validation, which succeeded. We're going to migrate the MySQL virtual machine, powered on, wait 60 seconds, web server, and so on. So it's following the recovery plan orchestration that I showed you previously. This is going to take a few minutes, so let's just wait for this to be done. Okay, now you can see that the recovery plan actually went through and initiated everything. The migration is complete, the application's powered on, and you can see here that I started at 3:05 in the afternoon and ended at 3:10, so approximately 5 minutes to actually migrate this 3-tier application. Now, of course, that's the easy part, right? Getting the data to the other site, that's easy. People have been doing that for years. The question is, how hard is it, or how easy is it to actually stand up a multi-tier application at recovery and have the security policies follow it? So let's actually access and look at the application now real quick. Let's go back into our application and automation manager here. Let's look at our services. You can see here web server, MySQL, HA proxy server. You can see here it's on a different network now, 10.0.201.100. That's a network that's actually in my Nutanix cluster in AWS. You can see here that the cluster now is on Outer Rim, which is a cluster in AWS. Let's actually access the application now. Copy the IP address. And now you can see that I'm accessing the application, and you can see the changes that we made, the additions that we made when it was on premises. The tasks that we added actually followed as well. So just basically using the protection policies and the recovery plans, which are our LEAP solution within our management stack of Prism, very, very simply integrated into Prism, set it up within minutes, and then assign policies to categories. So as you create applications and you deploy applications, being able to tag those applications either on instantiation when you actually deploy them or anytime during the life cycle of the application makes this process very, very simple. So you can imagine, bigger picture. So say you use a change management system like ServiceNow and you request an application, and that application asks you if you want a specific protection policy. Maybe you have a platinum, gold, silver methodology, right, around your protection scheme. Maybe adding it to the backup server, adding a security policy around microsegmentation and network segmentation. Having that all done as I request the application, it goes through the approval process within ServiceNow and then calls the blueprint and the automation framework within Prism via API. Very, very slick, very simple, very cloud-like, right? So this whole idea of this solution is to be very self-service driven, automated, etc., and making it very, very easy. Now the question is, now I can access this, but did security policies follow? Well, let's go back to the actual workstation and see if I can access this app again. So let's go back to the workstation. Let's log in again. Let's see if we can get to this now. 10.0.201.100. And you can see here I still can't get to this application, right? So it's being blocked.